Hey, how's it going? So this is going to be video number 1 out of 75. We're going to first go over a strategy on how to prepare for this series. I'm going to go over high level, identifying 7 or maybe potentially 8 sections I think you should focus your efforts on. We're going to go talk about what type of questions they will be, and we'll end it off with the first question out of the 75. So if you're still interested, stay tuned. All right. So before we begin, I want us to focus our attention on identifying key segments of Leetcode to focus our efforts on. Now, in order to be super effective, we also have to understand how to allocate our time. So I've identified 8 sections I think you should focus your efforts on. I divided these sections into 3 tiers. Tier 1, you can see it as the absolutely fundamental basic things that you should know and learn at the very minimum. Okay. Tier 2 are section of things that, if you want to get into, say, more better like FANG groups, you probably should get to know these segments as well. If you want to go tier 3, then these are all added bonuses. So let me go over what tier 1 is all about, right? In tier 1, we're going to focus on 3 things, which is arrays, how to play with arrays, how to manipulate it, and how to do all the questions relating to arrays. Second one is strings, which is string manipulation, word manipulation, mumbo jumbo like that. We're going to focus on that. And then number 3, we're going to look into trees, tree traversal. So tree traversals are things like a hierarchy. These are things that are very common in the workplace. So these are the first, I would say, if I were to bucket it all, are the 3 things that fall into tier 1. In tier 2, we could look at things like graphs, how to look things in more like a spiderweb things, matrices, and also dynamic programming. And finally, we will go over binary and, of course, the biggest meme of all, linked lists. Okay, these are the things that we're going to go through out of the 75 questions that we're going to go. I'm going to start off with array type questions and then move it along. Okay, so stay tuned and we're going to go through our first question. Okay, all right, so let's start with the first question. The question is called 2 sums. Let's read the question. Given an array of integer nums and the integer target, return indices of 2 numbers such that they add up to the target. You may assume that each input have exactly 1 solution, and you may not use the same element twice. All right, so what does this mean, right? In a very simple terms here, you're simply given an array of numbers. You could think about it as, stocks, right? Stock numbers. And you're given a target. A target basically is the 2 numbers that you need to get added together. Well, that's your target, right? So in here, we simply need to go and check whether or not we can write an algorithm to identify 2 values within an array that add up to a target, right? So let's look for first example. In the first example, you can see, the first 2 value here, if you add it together, you're going to get your target. Return that. Cool. But one of the key things here in this question, nowhere in this question says that the input array is going to be sorted, right? So you have to make sure to pay close attention to some of these problems. If they don't tell you, don't assume. So here's an example number 2, where you have an array that's not sorted. You still find a number 6. So what do? You get the last 2 values here, and those indices are 1 and 2, and you return those 2 indices. And finally, they have an example here where they're giving you repeated numbers, right? So it's just to tell you that the input array that's going to be coming in can be, unsorted, can be duplicated, right? And also here, it shows you some other assumptions you can look at, right? The length is always going to be bigger than 2, etc. And you cannot exceed these numbers over here. That's totally fine. And the key thing here that they bold is only 1 valid answer exists, right? Okay, cool. So you know that. So before we begin, I always like to have a quick example, right? A self-constructed example. So let's do the 1, 2, 3, 7 or 6, and a 1. Cool. And just say we want to find a target of 7. Okay, so before we begin, let's take a look. Like, what do we need to do in this array to find two numbers that add up to 7, right? Before you think about, coding, let's look at it. So I know instinctively I need to go, at the very least, go through this array once, right? Because you're trying to go through this whole array and find two numbers, right? So how can you find two numbers if you don't go through the whole array? So at the very minimum, you need to go through the whole array. So we know that at the very minimum, we need to do that. So let's write that as a note. Iterate, or let's put it this way. Go through the whole array. Okay, so what do we do when we go through the whole array? We're going to pick the first value, right? So I'm going to pick the first value. So what do you do? In this case, it'll be 1. Right? So what? You got 1. Now what do you need to do? Well, before you stop, I'm going to go, okay, well, I need to remember, okay, this is 1, but I need to check whether or not my remaining bits will add up to give me my target number, right? So I still need to continue to, once I iterate the first value, I need to iterate again to check if the following values would give me to the next number. So I'll go through the remaining array, go through remaining array and check if there is a value that will give me bingo. Okay, so simple enough. And one of the key things that's in this question is that there will always be one solution, right? So that's helpful. So you know that you don't have to put any error checks. I think this question is really designed to get you warmed up. Of course, they don't have to say this, and they can make things a little bit more difficult. But since it's our first question, and they specifically gave us this assumption, we can actually code a solution and assume that there will always be a solution, right? So if you go through it once and check it here, you'll always find a value, right? And keynote here, if you have 1 here, the solution here would be 6, right? But what if, oh, actually, this won't be right because there's only one solution. Let's make this some big number. There we go. That's more like it. All right. Okay, cool. So there will always be one solution, this and that. So what if your question was like 5? What do you do? Well, you have to get 2 and 3. Okay? It's the same process in here. So let's actually put some code to our pseudocode. So let's go through it. Go through an array. So let's write our function header, which is going to be to sum. We're given the nums as a parameter and a target, right? And then we're going to do the first step, which is go through the first array. So what do? For loops. All right, let I equals to 0. I is less than, less than nums dot length, because we don't want to go and iterate above and beyond this array size. So let's only go up to this array length, right? Less than that array length. And I will be plus plus. That's the rate of going through here. Okay, that's this first step here. You've gone through the array. You pick the first value, right? So how do you pick the first value? Well, you go nums and you use the index. That's your first value, right? But that's not going to be your solution, right? So we have to go through the second remaining parts. So what do we need to do? We need to start from the second indice, right? So how do we do that? And we have to go through the remaining part. So we got to write a loop that goes to the second element. So for, and just say let j equals to I, which in this case, in the first iteration, that's at 0. So I plus j. Oh, no, that's wrong. I plus I plus j. Wait, no. I plus 1. That's right. I'm getting it's late right now and I'm losing my mind. Okay, so j less than nums dot length j plus plus. So you're iterating through. Great. Now what? All right, so you're checking this number and then you're checking the rest to find the solution, but in this case you're not going to find it. So you're going to start checking the second one and then check the remaining to see if you find the solution, right? So if you find a solution, and of course there's always one solution, what can you do? Well, we could check if my first value, you're picking your first value, right? If my nums at I plus my nums at j add up to my target, what do? We will just return the two indices, which is I and j. And in this case, because there's always going to be a solution, we know that we don't have to put any error cases. We know that this will always produce a solution. You're always going to get a case like this. So we can actually write this code, and I think it should be sufficient. So let's run it. Cool, it's great. We got a solution. Now, even though this is a solution, we always want to check whether or not this is a optimal solution or not, right? So one way to check whether or not this is optimal is I always like to look at a couple of things. Wait, but before we do that, let's submit and see if it works. Cool, it works, but it's slow as hell. Okay, cool. So let's try to find an optimal solution. So how do we do that? So I always recommend people to break down two things you want to look at. You want to look at space, and you want to look at time, right? How much space is this particular algo take? Well, you're not creating any new variables. You're not doing anything, so it's constantly only going to be constant. No fun. So how much time? So we know that we're going to go through the array once, but before we even finish the first array, we have to go through it internally again. So for will basically mean that we got to go through it O of n times n, which is effectively the power of 2, right? So we know that, okay, this thing is slow. This thing is pretty fast, and we're good. So, so what can we do if we're asked to improve this particular algorithm, right? Because sometimes we got to improve this time. So what do? We need to improve this. Maybe we could trade off some of this to do this, right? So let's look at it. When we look for a solution, when we go for our first pass, we're going like 1, we're checking 2, 3, 6, 11. But then we do something really inefficient. We're going to the next value here and then rechecking 3, 6, and 11, and then rechecking. So maybe we know that this second loop here, this is the slow thing, right? It's kind of slow. So what can we do to improve this particular element? So remember, we're going back to the very first principles, which is, all right, let's look at the time, let's look at the space. So in space-wise, maybe you could sacrifice a little bit of space to improve on time. So what is space? When you think about space, it's just another fancy word for, different types of data structures. Can we create a data structure that can help us, right? Can we, when we think about data structures, is like either we, mutate something, which is a bad practice, or we can create a net new variable that stores something for us while we iterate through this particular array once. And we could just reference that particular space, right? That memory, effectively, right? So, as you think about this problem, you're thinking, okay, well, what are a couple of data structures available to us, or some simple data structures, right? What can we have? Because we're going to go through this array, and we're going to try to look up something, but we don't want to spend a long time looking it up because that's going to defeat the purpose. You're going to, you don't want to look up longer, because if you look up longer, you're just going to maintain the slow speed. So what's a constant lookup? We want to have a constant lookup type of, and let's look at all our data structures. Which one would have constant lookup? Well, there's something called dictionaries, right? Or, hash maps or whatnot. But hash map, if you want to go detail, it's somewhat different. But we can use a dictionary for this. So what does that really mean? In JavaScript, we can just simply use an object, right? So let's see if we can create something to help us. So when we look at this, right, we're basically going, okay, well, my first value is 1. I need to find a 4 in the remaining array. See, I already set the question. I need to find 4. But how do I know I need to find 4, right? Maybe we should store this little logic, and then we can reference it back. So by doing that, okay, if I stored a 4, so for example, in this case, if we go to the first one, and I stored my key will be 4, and index will be 0, I'm storing the difference between these two, okay? Because as I go through here and say, all right, is this equal to 4? When I look at, I could go and reference my dictionary. Does that have a 4? No, has a key. So what do? I can create another one here, 3, index 1. And then we go to next value, right? Wait. Yeah, Cool. Looking for 3. So we go to the next value. Does this contain does this my dictionary contain a 3? Oh, it does. So there you go. It contains a 3, and know that its associated pair is actually on index C1, which is the 2. So therefore, we got our solution. So here we go. That seems like a solution that could work. So why don't we try it out? Let's remove this thing that is the slow segment, right? And in replace, we're going to replace something here, which is going to be, let's create a dictionary, or let's call it memory. Memory, because I have a bad memory here. So as we iterate, what do? We're going to check this memory. If my memory is correct, at position nums at I, so we're just saying, does 1 contain in this memory? No. If that is equals to undefined, so it doesn't exist there, what do? If it doesn't exist, well, we're gonna have to do something. We're gonna have to basically find the difference, right? So we're gonna go and say memory at the position of nums at I minus target. Hold on, target. So we're gonna take this target, less this. All right. Will equal to, effectively, the index. Cool. So in this case, we're gonna go, okay, my memory, this number right here is gonna be my target, which is 5 minus 1, right? 5 minus 1 will make this 3. This will be 3, right? 4 as your key, and you're saying your indice will be 0. All right, that seems like it's cool. So if it doesn't, so what if it does exist in this memory in this case? If it does exist, then we simply just go bingo, return our indices, which is going to be your I and also the memory at nums at I, which is yeah. So this is basically checking as you go to number 3 if it exists as a key in this dictionary, which it does. It's going to return a 1. So this could be 1 1. So let's check this out if it works. Now let me comment this out. Boop, boop. Great, it works. Now I know the order here. It never said the order, doesn't matter, so I can always reverse the order. But just for argument's sake, I'll adjust that. Here, bloop, bloop, bloop. And here like this. Run. Cool, let's submit this. And whoa, we improved in speed. All right, cool. So let's take a look at what the space complexity of this particular algorithm would be, right? We look at it, all right. So we improved it, we improved this, so we only have to go through one pass. We're only going through it once, right? And over here, we're only creating a memory of up to an n. All right, so we improved it by a factor of n with a trade-off of space of n, right? That's a slight improvement, right? We always have to think about, okay, well, we did this, that's great, and that's a slight improvement, but can we make this even more efficient, right? Let's think about it. Can we make this even more efficient? So let's go through that same process. Okay. So what can we do here that is kind of slow? When we're looking at this, we're still trading off something that's quite big in here, right? So maybe we don't need to check this. We don't need to go and store every single element. Now, when we look at like how can we solve this problem without putting in every single element, we can look at, okay, well, is there something I can do to my input array as it comes in, such that I could probably benefit from the natural behaviors of the input array? So let's think about that. So one way you can think about it is thinking, okay, well, if you have your nums here, right? We know that the array is not really, it's not really sorted, But can we sort this array? We probably can. If you sort this array, what kind of attributes do you have in this array? We know the rightmost segment is going to be the highest, and we know the leftmost segment is going to be lowest, right? So what we can actually try to do, instead of like going just dumbly going through like, okay, from 1, 2, 3, 6, and 11 to get our solution, we can actually think about, okay, can we use the behavior of our input to help solve this particular question? Now, think about it. I just said it. You can bring it here and you can sort this array, right? So once you sort it, think about just, I want to leave this with the audience here. Think about how you can potentially solve this problem, okay? You know that your rightmost corner is going to be the biggest number, and you know your leftmost corner is going to be the smallest particular element. So what can you get out of that? Here's a hint. If you start not just like going from one way to another, but you're using, you know, 2 pointers that point to the 1 and the 11. If you add 1 and the 11 or together, that's bigger than 5. What do? You can move the right pointer down this way. Does 1 plus 6 equal to 5? No, it's greater. Then I'll move down to here. Does 1 plus 3 equals to 5? No. Then move the left pointer here. So by using pointers, I don't need to store the actual n value anymore. Okay? And I'm only iterating through this once, right, of O and N. The only downside is that I need to ensure that my array is sorted. Now, any sorted algorithms, you could go and look up all these other different things, but we could probably improve this slightly through this way. Now, I'm not going to code up a solution for that. I'll leave it for you guys to check it out and try to solve it yourself. But I hope you guys enjoyed this first video. I'm going to try to create more on the following days, and hopefully this is helpful in your journey. So this is 1 of 75. Wait for next week for number 2. See you guys.